In this video, I want to move away from talking about the kidneys and pay a little bit of attention to the other urinary organs. By other urinary organs, I'm of course speaking of the ureters, both of them, your right ureter and your left ureter, the urinary bladder, and the urethra. The paired ureters are the tubes that carry urine from the kidneys, where the urine is made, all the way down to the urinary bladder, where that urine is stored until time for release. And the urethra carries urine from the bladder out of the body. Here you're looking at a cross-section of the ureter, so you're able to see the histology of the ureter very well. Here you're looking at a cross-section through one of the ureters, so you can see the different layers of tissue. You have the lumen, the center, the empty center that urine flows through. You have the epithelium, lining that lumen, the lamina propria, connective tissue, supporting the epithelium. And then outside of the lamina propria, you have the muscular layers. There's actually a longitudinal muscular layer and a circular muscular layer. So just like in the digestive tract, if you think of the ureter as a long tube, you have a layer of muscle that wraps around like that. That's a circular layer, and a layer that runs parallel to the length of the ureter. That's the longitudinal layer. So the ureters are actually a really muscular tube, and this is because the ureters are not passively carrying urine to the bladder. They actually do peristalsis, so peristaltic waves of smooth muscle contraction move urine through the ureter down to the bladder. The epithelium of the ureter is also important and a little bit distinct from what you find in other systems of the body. It's called transitional epithelium. If you think back to learning about the tissues, remember that transitional epithelium is found in organs like the ureters and the bladder that need to be able to expand as they fill with urine. Transitional epithelium is a very specialized type of epithelium. It's a type of stratified epithelium, so the basement membrane is located there or along there, and you have multiple layers of epithelial cells. But it's not just any old stratified membrane, because this top layer of cells can actually change shape. So when the ureter, and the bladder as well, because the bladder also has transitional epithelium, when it's empty and not filled with urine, this top layer of cells takes on this kind of puffy, marshmallowy look. They look almost more cuboidal, but like a really puffy, cushy cuboidal. When the ureter and the bladder do have urine in them, and so the organ is very stretched out, full of urine, this top layer of cells becomes almost more squamous-like. It's a little bit hard to see in this one, but I'll kind of sketch it in for you. They flatten out. So this is why transitional epithelium helps with the function of the ureter and the bladder, helps them to expand in order to hold urine. From the ureters, we move down into the bladder. As I mentioned, the bladder has transitional epithelium. It collapses into folds called rugae when empty, similar to the folds of the stomach, which are also called rugae. So the collapsing into folds allows it to collapse down to a smaller state and expand to fill and hold rather significant quantities of urine. The bladder is also a highly muscular organ. If you think about contracting your muscles to force urine out, the muscle around the bladder is referred to as the detrusor muscle. So that's this layer in there. Let's take a quick look at what the detrusor muscle looks like under the microscope. This is a cross-section through the wall of the bladder. The transitional epithelium is up here, the underlying lamina propria, submucosa. The detrusor muscle is this very significant part of the wall of the bladder. This whole thing is the detrusor muscle. So the bladder is also highly muscular so that you can contract and force fluid out. The openings of the ureters are actually located here on the base of the bladder, so the bladder fills from the bottom. And then at the base of the bladder, you have the sphincters that open to allow urine to flow into the urethra. And you actually have two sphincters to your bladder. You have an internal urethral sphincter that's under involuntary control, so this you cannot control when this opens. You also have the external urethral sphincter that is skeletal muscle, and it's under voluntary control. So it's not always extremely conscious control, but you can control, at least semi-consciously, when this external urethral sphincter opens. From the bladder, urine passes into the urethra. The mucosa of the urethra has a bit of a variable epithelium. It's transitional epithelium up near the bladder, but it becomes pseudostratified columnar for most of the urethra, and stratified squamous right near the external orifice, where there's a little protection needed from outside intrusion. The urethra is a little bit different between the genders. So what you're looking at over here, of course, is the pathway of the male urethra, and here is the pathway of the female urethra. The female urethra is much shorter, only about 3 to 4 centimeters long on average. In males, the urethra is much longer because it passes through the penis. Also in males, the urethra carries semen as well as urine. Here's a different look at the relationship between the bladder and the urethra in both females and males. Here's the bladder and the female, the urethra leading down slightly anterior to the vaginal opening, and that's the uterus. Muscular as the bladder is, it's not as muscular as the uterus. In males, this is the male bladder, and then you can trace the path of the urethra down and out. The micturition reflex is the more technical term for the process of urinating. So micturition is basically urination. This reflex is triggered when your bladder becomes full. There are stretch receptors, mechanical receptors that detect how much urine is in the bladder by detecting how stretched the wall of the bladder is. And there is, when they detect fullness, there's a local reflex that acts immediately on the detrusor muscle that stimulates muscle contraction, which actually raises bladder pressure. So it's like if you're a little bit full, you get even more of an impulse, a stronger impulse. That information about stretch is also relayed up to the cerebral cortex and to the thalamus of the brain so that you get a conscious sensation. You become consciously aware that your bladder is full. And if you're in a situation where it's appropriate, your brain then relaxes the external urethral sphincter. When you relax the external urethral sphincter, it's actually that triggers involuntary relaxation of the internal urethral sphincter. So there's almost like a secondary little reflex that says when your external urethral sphincter is open, your internal urethral sphincter needs to open too, so that urine can pass out. Some people suffer from urinary incontinence, which happens from damage to the sphincter muscles. It's actually fairly common for women who've given birth to damage their urinary sphincter muscles and experience urinary incontinence, which hopefully for most women goes away after a while. Okay, after studying this video, you should be able to talk about both the gross anatomy and the histology of these non-kidney urinary organs. You should be able to discuss the significance of transitional epithelium in the urinary system, talk about how urine is moved through the ureters, those peristaltic contractions through the ureter, and how it's moved out of the bladder through the contraction of the detrusor muscle, And you should be able to describe the micturition reflex.